The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody. Welcome to the final day of the What's New in TopSolid 2021 webinars. Today we'll be focusing on the TopSolid tooling products with regards to ejection mold design and die design and electrodes. Okay, so let's go ahead and get started. There's a handful of improvements to the TopSolid'Split functionality. To begin with, the parting edge command has been sped up significantly. It should be about 90% faster. The creating of shells should be about 40% faster. And then we've also improved the calculation time of core and cavity blocks. With regards when the dialog box opens, it's 30% faster, and we've also improved the calculation time of the insert surfaces when using faces mode, and that's about 75% faster. So the first thing I'm going to show you has to do with the pre-study mode. So in pre-study mode, this is where you will do a core cavity split, but not really. Okay, the whole idea here is maybe it's a complex part. Granted, I know this is not a complex part, but bear with me. So you start with your stock block, however the stock needs to be. And then you have a mode down here called pre-study. This mode has existed for quite some time. Basically what the pre-study mode does is it creates dummy cavities and dummy cores around your part based on the stock size that you chose. For example, if I go into my shapes here and I turn off the core block, you see the cavity. And just to differentiate them a little bit better, let's go ahead and change some colors. Make them a little transparent even, why not? We'll go core, and we'll change this one to be, I don't know, blue or something. Make it super transparent. Now you can see the pre-study blocks. If we go and activate a cut, and I've had these predefined already, so it's just cutting through the XZ plane. If I turn off the core block, you see what the cavity might look like, and then you see what the core might look like. And the whole idea here is on a complex part, and you want to just fast forward to getting your proof of concept done, your assembly drawings roughed in, so you can get sign off by your client. You start with the pre-study mode, you skip the core cavity split altogether. You can make the core cavity blocks like this, go put it into a mold. You can start adding ejector pins, water lines, all sorts of fun things. Okay, so it's just a way to speed it up. So in the pre-study mode now, the improvement basically is it now includes the shape to split as well. So that's the basic improvement there. As always, if you guys have questions, by all means type them into your question section of the interface. Okay, number of shells. I'm going to go to this part here, my famous little part. And I'm going to showcase a new command here. That's not even a new command, it's an optimized command. So let's go to split blocks. Okay, we'll give it a shrink because we can. And then let's go find some parting lines. Perfect. And I'm going to start selecting parting edges. Okay, let me change my rendering mode here. All right, so we have our first parting edge. And what you're going to see here is in the history tree, it lists your parting edge as it used to be, but now in parentheses, it's telling you the current status of the part. Okay, so the number of shells obtained after each parting edge operation is now displayed in the operations tree. So here we have one parting edge. If we go here, we have parting edge number 2. Again, no parting. If we go here, parting edge number 3, again, no parting. And if I turn this off and I select here, boom, we have 2 shells. So it's just a way to look in history to find out A, when the parting is completed, and B, how many shells it creates. Okay? Perfect. Moving right along. We have a new way of connecting parting edges. It's called edge path between vertices. So as you can see here on this part, we have it missing a parting edge along the side here, and we need help maybe finding that path a little bit. So if I go to my parting edge command, I can go and hit the additional inputs here, and I can go edge path between vertices. It's going to ask you for a start and an end vertex. I'm going to zoom up here to make sure I'm getting the right vertex. And you see here there's no parting edge in between there. That's okay. We select there, and the software automatically finds the shortest path through there. Now, if you wanted to, you can make sure it passes through specific edges. So for example, if I was to select this edge here, you can see it redirects, comes up, redirects over here as well. If I want to add another edge right there, it redirects, comes to that edge there. If I delete all of that, and maybe it's up here that I want to pass through, I think you get the idea. So this path between vertices, the whole point of it is to just speed up the whole parting line creation process. Alrighty. Okay, this next one is kind of awesome. It's tangent lateral extensions. So you can, well here, let's just go do it. So if I go to parting surface, we're on extended, right? Or extruded, whatever you want to call it. I want to go from this edge here. Let's set these to none really quick. To this edge there. Okay. So in the past, of course, you know that you can double click on these balls and it will give an extension. Okay, and you get extensions like that. But now you have this arrow, and if you double click on the arrow, it's a tangent extension. Of course, you can modify it over here as well, but I think it's just as easy to double click out here. So now you have the ability to quickly create tangent extensions off of the main extension parting surface. All right. Lastly, with updates to TopSolid'Split is an automatic parting surface improvement. Basically, the calculation time has been optimized from 50 to 80% time savings according to the type of part, and the results are much better. Let's have a look. So if I go to my automatic parting surfaces, and again, these are for the external parting surfaces. It automatically found the external parting surface, which is great. You can hit compute surfaces, and now what you will see is that it creates as nice of an automatic parting surface as possible. Nothing is intersecting itself. In versions before, sometimes you'd get some self-intersecting surfaces, so you'd have to exclude those. All of the standard automatic parting surface functions still exist, so if you didn't want to use a specific parting surface like that one, you can uncheck it, and then you can go deal with this yourself. Okay? And that's that. All right, so moving on, we're going to talk about TopSolid'Mold next. I'm just going to bring this one up really quick. So just a real quick point about ejector pins. I'll let it finish loading. So when you're doing ejector pins by sketch, you'll notice, if you watch up here, there's now a preview icon. So if you're building a really, really big, or if you're putting a lot of ejector pins in at once, sometimes the preview generation can be quite time consuming. So you can turn that off prior to the selection of your sketch, and then just let it do the calculation normally. So you're in full control over whether you want to see the preview or not of that mode. Okay, cooling. So we've created or improved the waterline command to allow the creation on an existing 3D sketch. You can create cooling circuits on the 3D sketches, which offers many new options: standard cooling circuits based on sketch components, symmetrical repetition of a circuit by repeating the sketch, repetitions of segments within the sketch, associativity between the sketch and the cooling circuit. Let's have a look. So if I go into here to cooling circuit, this was the original mode. This is where you draw your cooling sketch dynamically. And here, this is our existing mode. Okay, so this is the new mode. We're going to start by selecting our sketches. I have automatic detection selected for the parts management. Okay, again, on a small to medium sized part, automatic is fine. It just tries to detect all of the shapes that intersect with your sketches so that you know which shapes to process for water lines. So I have that sketch. I have another sketch for my baffle lines there, and another sketch for my baffle points there. Okay, you have your normal cooling circuit style. You have your drillings. We'll talk about the entry face here in a second. And then you have your baffle lines. I want my baffles to be included through that face. Okay, so we hit OK, and then the software will automatically apply the cooling circuit based on those requirements. Okay, if you have some project templates for baffles or whatever, it's going to ask you to select them. And voila, waterline circuit and baffle line. And the baffle line, of course, is following that crazy 3D part. Okay. From there, if you're smart about your design, this sketch was just a repetition. Okay. So because it was a repetition, I could parameterize it. So if I go to my parameters, here's the number of instances in that sketch pattern. Why don't I make it 6? Then it's going to replay everything and it's going to update. And like that, you have more of your water lines and more of the baffles and so on. Okay. The other thing you can do, so if we go into here, let's see, cooling circuit. We want to edit cooling circuit sketch. Oops, not that, pardon me. There we go. So now we're in the cooling circuit. So another new command that exists now is baffle line point command. So as opposed to you having to create a point and then go and select the point, now you can do it all at one shot. And as I go and select and add them to my lines, it is just going to add the baffles and the drillings dynamically. So it's just a faster way to get your baffles in. Okay. All right, from there, I'm going to just bring my little cheat sheet over and let me go and edit this cooling circuit. One more improvement with water lines has to do down here where you have entry face selection. So when we're automating selections, if you look at my sample image here, you can now consider certain faces of the part as the entry face of the drillings created by the cooling sketch. So, in this case, to minimize setups, maybe we want this blue drilling here drilled from this face. So when you want to specify where the drillings come from, you can activate this and you can select specific drillings or specific faces to control it. Okay. If we look here, my drillings are happening from the parting line side over here. So if I activate this and select that face, it should invert them once we rebuild. And apparently I misselected something, but that's the idea of the command. Not all demos can be perfect, right? All right, so that's it for cooling circuits. Now let's talk about angle pins. And for this one, oops, did I close? I didn't. Hold on one sec. Oh, there's one more, sorry, one more cooling circuit command. I'm just gonna drag that back over. And Let's just go watch the video for this one. All right, so when we go into our cooling circuit, we want to edit our cooling circuit. We've now made it possible to be able to apply an offset on the positioning of mold components for the water lines. So here you have an offset control, and you can just go in here directly and edit that location, and you can see you can drive that deeper or shallower or whatever. Cool. All right, next improvement we're going to talk about is the real stroke parameter for angle pins. And it's kind of interesting. So when you insert an angle pin, okay, we're going to do it the normal way. We select the moving component, we select the frame to reference, and we select the positioning plane or planar face. Okay, there's your angle pin, great. From there, okay, you can maybe type in your measured stroke or do a measured stroke. But down at the bottom, based on the current criteria, it's telling you what the real stroke actually is going to be. The new improvement is the ability to create a parameter, as you see with that checkbox right there. Now, why would we want to create a parameter? Because then we can pass this parameter to other aspects of the design for this feature. So there's the stroke, and you can see it's stroke angle pin 1, and it's giving you the real-time measurement. And now here, I'm just going to fast forward this video just a little bit. Okay. Here, we're going to go add another component, just our spring stop, for example. And then for the drivers, for the slot offset, we're going to use the stroke. Okay, and that slot offset is for the detent that it's going to put into the slide carrier. Let's fast forward this so we show the slide carrier, and it's right here. It's this spacing. So this spacing now will match the real stroke of the angle pin. If you change the angle pin length, this will automatically update. So that's the whole idea behind it. So now if we come down here and we say we want we want more stroke. Okay, that's the real stroke based on those criteria. Okay, the creation of the parameter already exists, but you notice that the detent offset just updated as well. So we're just doing what we can to help ensure that everything is related that can be related to speed up your design process. Cool. All right, next, we made a small improvement to drilling collisions. Let's have a look. So this is a standard drilling collisions command inside of TopSolid. It's been completely redesigned to be able to test for collisions between all the drillings available in all the mold parts, whether the drillings are performed by an operation in the mold or whether they are created locally in the parts by the user. The command automates the launch of the drilling collisions command available in any part document. You do not need to open every part. This allows the different collisions identified in each part of the mold to be grouped in the collisions folder and the entities tree. The collisions between the different cooling drillings are automatically excluded. Okay, so there's your margin. Hit OK, and now this is showing any potential collisions. And this is a silly test that we're running because it's telling you you're colliding with components. But it's just to show you that it's been revamped. Okay. So let's go on to the mold stroke parameter improvement. So with the ejection stroke parameter, this is new. So we can do it based on a couple of different modes: inferior and superior block extremities, part extremities, as well as superior block extremities, part and superior. So why is this important? Because now we can use any one of those within the mold simulation. Just to make it more realistic. And there you go. Okay, another little improvement is having to do with the open tooling configuration. The new open tooling configuration option allows you to create and maintain a configuration of the tooling in open position. So you can see here with the simulation management, we can create a configuration automatically now for you. All right, get out of that, and then we rebuild, and then we can actually set that configuration current. And now it shows the mold in open configuration. Because that configuration exists here, it could also be used in drafting, for example, if you want to create a drawing in the open configuration. Can do collision checks based on that configuration as well to see if there's anything that's colliding during the open. All right, and last improvement has to do with decorrelation. You can now decorrelate a mold. The decorrelate command allows you to specify the links between the mold and one or more of its synchronized documents. All entities referencing an entity in another document are replaced by a basic entity. So one of the ideas behind this is that at the end of the mold design and before editing it and putting it into production, this operation allows you to manage independent life cycles of each part and also allows you to modify a mold very locally without impacting all the other parts of the mold. So it's up to you on what you want to decorrelate. You can decorrelate everything, part of it, whatever, but the option exists now to, again, just give you better ability to control your design. Okay. So if we decorrelate everything, you can see synchronizations are removed. And these are all the isolated objects. It's probably really more handy for very large molds, if I had an opinion about it. Okay, so that's the end of the improvements for TopSolid'Split and Mold. Later on this morning at 11 a.m. Central Time, we will go over electrode and strip design and progress improvements. So if there's no questions, thank you for attending, and we'll see you guys then.